Okay, part E. So it says consider this equation, z squared plus az plus 12 equals 0. So b is equal to 12. Now just to preface this, guys, this video, this question is really hard. I don't know why they've only given it 3 marks. As far as I can tell, it's worth about 10 marks. It took me ages to figure out even how to do it. So just a word of warning. This is not 3 marks worth of working that I'm about to do here. Anyway, b is equal to 12 here. And from part A, we know that a squared minus 3b equals 0. So a squared minus 3 times 12, or 36, equals 0. A squared equals 36. A is equal to, let me just move it up here, guys, so I have space. A is equal to, plus or minus 6. Okay, now the goal is to deduce that only one equilateral triangle can be formed from the point O and the roots of this equation. So this equation is, okay, we have 2 equations. Now I'm going to do for A, I have to consider both. For A is equal to 6, and I'll do A is equal to negative 6 after. So for A is equal to 6, I have z squared plus 6z plus 12 equals 0. I need to find the roots of this equation. The roots I can get from the quadratic formula. Minus b, minus 6, plus or minus the square root of b squared minus 4ac, 48, all over 2 times 1, which is 2a, which equals minus 6 plus or minus the square root of negative 12 over 2. This, guys, is equal to, well, I'll just do this quite quickly, guys. Negative 6 over 2 is negative 3, plus or minus, this is root 4 times root negative 3, which is actually going to be, the root 4 cancels with this 2, and we're left with root 3i. Okay, so just make sure you can turn that into this. That's for A is equal to 6. For A equals negative 6, we have z squared minus 6z plus 12 equals 0. Z equals, this time 6, plus or minus square root of the same thing actually, so I can just put negative 12 all over 2, and then I can have 3 plus or minus root 3i. Okay, so these are the roots. I can have this one, these two, or these two. And I need to show that there can only be one equilateral triangle formed from the roots of this equation, right? So what I'm going to do, guys, is I'm going to draw this. And I'm actually going to draw 4 different types. So I can have this one, and this one, or this one, and this one. Okay. Now this is going to be for my minus 3 plus or minus root 3. So this guy can be minus 3 plus or minus root 3i is here, and this guy is here. This is my z1. This is my z1, and this is my z2. Now this is minus 3 plus or minus root 3. That would give me an angle, and guys, this one is the same, but I'm just going to switch the z1 and the z2. So this time this guy's z1 and this guy's z2. Now for this guy, if he's z1, This minus 3 plus or minus root 3i means this angle here, if we do inverse tan of 3 over root 3, which is actually going to be, if I do inverse tan, of root 3 over 3, this angle here has to be pi over 6. Now again, I'm skipping a lot, guys, just because, as I said, this is such a difficult question. But if you go back to basics of complex numbers, or to find the argument of complex numbers, this is pi over 6, and this is pi over 6. Hence, this is our equilateral triangle. But if this is Z1, it says here alpha minus theta has to be less than or between 0 and pi. So if this guy is alpha, so our Z1 has alpha. This guy's alpha, which is 7 pi over 6. So let's actually write this here. Alpha minus theta is equal to 7 pi over 6 minus this guy is 5 pi over 6, which is 2 pi over 6 or pi over 3. So that guy is fine. He has, and this is actually probably going to be our only solution, but he has an alpha minus, because look, this is alpha there, and this is theta there. So our alpha minus theta gives us pi over 3. Now, if we did it the other way, this guy would be alpha, him, and this guy would be theta. Then alpha minus theta is negative or less than 0. So this is not a possibility, not a solution. Okay, let's do it over here. We're going to do for this guy, our 3 plus or minus root 3. So it's the same kind of thing, except over here. So this guy is there, and this guy is here. Now let's make him Z1 and him Z2, and this guy will make him Z2 and this guy Z1. Now Z2 has theta and Z1 is alpha. So Z1 is alpha. So this guy is our alpha. And again, it's this is pi over 6. So this angle is still pi over 6. This angle is pi over 6. This angle is pi over 6. This angle is pi over 6. So it does still give us our pi over 3, which will be our equilateral triangle. But if that's alpha, and then this is theta, alpha minus theta here, alpha minus theta is equal to pi over 6 minus theta, which is now 11 pi over 6. 11 pi over 6, which is less than 0. So this is also no good. And then finally here, alpha is my Z1. So now that's my alpha. And my theta is this guy here. Here I have alpha minus theta is equal to 11 pi over 6 minus 1 pi over 6, which is 10 pi over 6. But this is bigger than, it has to be between 0 and pi, but this is bigger than pi. 10 pi over 6 is bigger than pi, therefore not a solution. Okay, so this one here is the only possible scenario. So it says, given that this, deduce that only one equilateral triangle can be formed from the point 0 and the roots of this equation. So this one, guys, is the only possible equilateral triangle. Only possible, let's just write only possible solution. These ones are not, because this guy angles less than 0, this guy angles less than 0, and this guy, the angle is greater than pi. Okay, I did say it was difficult, guys. I hope that makes sense. If you can at least follow it, then you've got a decent understanding of complex numbers. But to be fair, a very difficult question, and to be honest, quite I would argue quite a strange question. But I guess that's the point of the kind of last part of the last question in a paper. It's supposed to be strange or different or unusual. Okay, that's it, guys. That's the paper, and I'll see you for paper 2.